Everyone, so we're starting a new unit today. Still continue with circuits, but a little bit more of circuit diagrams, how circuits work, and things like that. So this is class 121. So today we're going to talk a little bit about how to draw circuit diagrams. We're going to talk about what a parallel circuit is. We already mentioned what a series circuit is. We'll go over that again. And we're going to talk about what a short circuit is. And we're going to be drawing circuit diagrams. We're going to be looking at what they look like in PhET. I'm going to emphasize a lot that the PhET simulations for this topic are incredible. I think you should not be doing anything with this topic without having PhET open, whether that's homework, class notes, whatever. I have the link for it here, and we'll talk about it in a little bit. So using your reference table, label the parts of the circuit diagram to the right. Okay, so this might not really look like anything, but there's a lot going on here. So on your reference table, you have circuit diagrams. So let's find where those are, or circuit symbols rather. Here they are. So this symbol here is a battery, okay, with these lines. And this symbol here is a resistor, that squiggly line. So this is a battery. And this is a resistor. And the things connecting them, these lines, are of course wires. Hopefully you don't need me to label that, but I'll label that anyway. Okay, the positive terminal of the battery is always the one with the longer side. Okay, so this is always the positive terminal, negative, positive, negative. All right. So drawing a couple more arrows to represent the current. So it's really important to note that current flows out of the positive terminal, goes around the circuit, through the resistor, down this way, and back into the negative terminal. All right. Notice that current flows out of the positive terminal and into the negative. This is called conventional current flow. All right, and we've spoken about that before. It's the flow of positive charges. Yes, we know that positive charges don't actually move, but in this class, whenever we talk about current, we're talking about conventional current, the flow of positive charges. So in another color, pencil or pen, draw and label the flow of electrons. So electrons are just the opposite. I'll label that, we'll do it in brown. So electrons go from negative to positive. So this would be the flow of, that's not brown. This would be the flow of electrons. But again, I want to emphasize that we do not follow electron current flow in this class. We follow positive current flow. Yes, electrons are what actually are moving, but that's just not what we do. All right? So draw a series circuit diagram in a box to the right containing one battery, one switch, one resistor, and two lamps rather. What I want to say is, remember, series circuit, there's only one path for the current to go through. All right, so look at the reference table for the symbols, and we're also going to make this in PhET. All right, so try it on your own first, and then we'll go over it together. All right, so we have a battery. Generally, you draw the battery on the left pointing up with the positive terminal up, positive. All right, then we have one switch, one resistor, and two lamps. Let's just look at what those look like. That's a switch. There's a resistor, and then two lamps. All right, or light bulbs, lamps, same thing. So it doesn't really matter the order. We'll do the switch first. Then we'll do a resistor here. Then we'll do one lamp here. Then maybe another lamp here. Now the order doesn't really matter, and it doesn't even matter what branch they're on. There are so many different ways to draw this. Another way I could have drawn this is I could have put them all like along the same thing. Like I could have taken the resistor and let's see, I could have put the resistor over here if I wanted to. So maybe I could have gone like this and then the resistor here. Doesn't really matter because there's one path for the current to go through. So it doesn't really matter the order. All right. And the current's going to go around. I'll just draw the way the current goes. It goes through this way. When the circuit is closed, of course, if the circuit's open, then there's no current going through it. All right. Again, current goes out of the positive and into the negative. Right, and again, these can be in any order. They could be on any side of the square if it looks like a square to you, or a rectangle. They could be on any side. It doesn't really matter. So let's make this in FET. All right, so we have a battery. All right, put some wires in. We have a resistor. That's what a resistor actually looks like. You see those in a lot of circuits. We have one lamp or a light bulb. I don't think they're lamps. I think they're just light bulbs. Yeah, just light bulbs. We have another light bulb. We'll connect those with some wire. Be careful when you try this on your own. Make sure that the different terminals are the ones that connect. So notice how I created this, how like everything's all in one row like that. It doesn't really matter. Make sure you do conventional current as well. Okay. Now I could have rearranged this a little bit. Like I could have put this here, and gotten rid of this. It doesn't really matter too much. All right, actually there's an issue there that needs to be connected. The different terminals have to connect. All right, so there's our circuit. That's what it would actually look like. You notice how these get lit up. The resistor slows down the current a little bit. Both of these light bulbs also have some resistance as well. All right, I'm going to get rid of this. I'm just going to throw this aside for now, and we're going to talk about a different type of circuit. All right. So as we said a few classes ago, a series circuit only has one path for the current to flow through. A circuit with multiple paths for the current to flow through is called a parallel circuit. So those are the two major types of circuits we're going to be talking about repeatedly in this unit. Series circuits, where it's just one loop. Parallel, where there are multiple paths for the current to go through. What does that look like exactly? So I think what I'm going to do is, well, it says here, redraw the first circuit as a parallel circuit. Get rid of the resistor, so there's going to be no more resistor, but there's going to be two lamps, okay? And a lamp is going to be in each path, okay? So let's draw what this looks like. Actually, let's just show you what a parallel circuit looks like and how it's different. So at first, the two lamps were one right after another, kind of like this, all right? And there was just one loop for the current to go through. That's a series circuit, one loop of current. Now let's talk about parallel circuits for a moment. All right. So in a parallel circuit, there are two different paths for the current to go down. This is like a regular series circuit, but in a parallel circuit, you create another path. Okay? So that the current has another option or another route to go. All right? This is a parallel circuit. Now I think I forgot to before, but I think I also mentioned putting a switch in. All right? So the switch, you want the switch to be somewhere where it could turn off both. I always say if you wanted to turn off everything in the circuit, put it right near the battery. So let's do that. We'll put it, doesn't matter before or after the battery. Let's put the switch right here. Okay, close the switch. My circuit's on. Circuit's off. Close the switch, circuit's on. Open the switch, circuit's off. All right. So here's my diagram. I have a battery. I always label the positive and the negative end. Then we have my switch. Then we have my first path with a lamp. Makes its own loop. And then my second path with a lamp. Okay. Now notice how the switch is turning off both lamps because it's not letting the current get past this point here. Current can't get past there, so it can't get to either lamp. All right. Now, how could you move this switch so that it only controls one lamp? So here's my advice. Always put it right before the current gets to the object you want to turn off. Okay, as close as you can. So if I get rid of this, okay, think about where I can put a switch so that it only turns off one of the lights. Okay, it doesn't matter which one, just pick one. So like I said, right before the current reaches that object, throw a switch in there. What that'll do is that'll let you control whether or not current goes through there. So right now, the switch is closed or is open, so no current can get to that first light bulb, so it's off. Close the switch, now it's on. Open the switch, now it's off. I can put a switch there too, so I can control both of them. All right, let's move this so it's a little easier to do. So I can turn this one off, turn this one off, turn this one on, turn this one on. All right. Now, hopefully you see an advantage of parallel circuits. Okay, I think the next question asks you to mention an advantage of parallel circuits. You can't do this with a series circuit. You can't have two switches controlling two different light bulbs. In a series circuit, since there's only one loop, if you put that switch in, it controls everything in that one loop. All right. So actually, let me kind of show you for a sec. So I'm going to have this, I'm going to have a switch. I'm going to have one light bulb, I'm going to have two light bulbs. Again, we're going to do a series circuit, so it's just going to be one loop of current. No second path of current for current to go through. All right, so right now that switch is open, so both lights are off. Closed, both switches are on. So there are advantages and disadvantages to parallel and series circuits. If I want to control two light bulbs with one switch, they're in series. If I want to control the light bulbs with different switches, they're in parallel. Your house has different series and parallel circuits all over it. Okay, there's no one that's necessarily better than the other, but there are advantages and disadvantages to each one. We're going to talk about those more and more. All you have to know right now, though, is that in a series circuit, there is one path for current, so that switch turns off everything. In a parallel circuit, there are multiple paths for current. Okay, so that switch, depending on where you put it, could turn off both lights, it could turn off one light. Again, advantages and disadvantages to both. We'll get into those more later. All right, so that, number 6A, you can put in your own words. All right, so we're still going to work with the parallel circuit. Lower the resistance of one of the light bulbs to 1 ohm. Describe what happens to the current through each bulb. So let's get rid of this. All right, so I'm going to move this over here. You can leave the switches in there. They don't really affect anything. Let's spread this out a little. So these switches make it, actually, they're kind of annoying to deal with. I'm going to get rid of them. Let's just put the regular old wires back in. All right, so now we're back. Okay, so I said turn one of them. So they're both at 10 ohms right now. Yeah, if you click on them, you see 10 ohms. So turn one of them down to 1 ohm. It doesn't matter which one. Let's do this one. All right. Mention what happened and write down what you see happening when that happens. So the one on the right is still 10. The one on the left is 1. So the one on the right has more resistance. The one on the left has less resistance. So hopefully you noticed the 10 ohm, no change in current. 1 ohm, more current. Okay. Hopefully that makes sense to you. As as resistance goes up, current goes down. As resistance goes down, current goes up, right? Hopefully it makes sense. Just the word resistance means it resists current. Okay, current always takes the path of least resistance, sort of. There's still current going through this light bulb on the right, but notice how this one on the left has a lot more current going through it because it wants to go that way. It's just easier for those electrons to move, for those positive charges to move, however you want to think about it, when there's less resistance in one path. Think about it, if you have 2 hallways you can go down. One hallway's got a lot of people in it. The other hallway has nobody in it. People are going to go down the hallway with nothing in it, okay? Because it'll allow traffic to flow through a little bit better, okay? Or you could think about it like the narrowness of the hallway. If you have a really narrow hallway like this light bulb on the right, a lot of resistance. You can't go through it quickly. Your really wide hallway, like this light bulb on the left, not a lot of resistance, a lot of current can fly right through there. So let's create a short circuit. So I'm going to get rid of that light bulb on the left entirely. Okay, and I'm going to create what we call a short circuit. So we're going to get rid of this light bulb. We're just going to connect these two wires. Now notice what's happening there. The light bulb on the right just, actually, I want to go back for a second. I'm going to create a short circuit actually on the right. I think it does a better job of depicting it. Okay, so notice how when we get to this junction up here, this one, current can either go straight through and go to where there's no resistance at all, or it can go down to where there is resistance in this light bulb. Which one do you think it's going to go to? Now there is still some current here, but that doesn't really matter because there is an infinite amount of current going through this outer loop here, which gets the battery really hot and creates a short circuit. All right, that's a big problem. So there's no resistance in this branch, so the current through that branch approaches infinity. Whenever you have a short circuit, you have an issue. Circuit's going to get really hot. So it says explain how closing the switch in numbers 1, 2, and 3 would result in a short circuit. So look what's going on here. When the switch is open, there is no current going through here at all, this branch, because there's no closed path. But when the circuit's open, there's current going this way. That's good. There's resistance there, no problem. But then when you close this switch then, here's what happens. Current wants to go this way too. But think about it. Is there resistance here? No, there is no resistance, okay? So that's a short circuit. Even though that circuit on the right is fine, or that portion of it on the right is fine, it doesn't matter. This closed loop where there's zero current or zero resistance is going to have way too much current. All right, look at this one here. So when the switch is open, as it is now, let's see, current can't go this way, but actually current can go nowhere. There's no circuit. This circuit won't work at all when it's open. But when we close this, current leaves and can go this way. That's okay, no problem there. There's resistance there, there's a light bulb there. But current's also going to go this way. That's bad. Because again, R equals 0 here. Therefore, current equals infinity. Bad, that's a short circuit. Now when the switch is open here, current can go this way, no problem. Regular old circuit. But once we close this, yeah, there's still current over here on the left, but you're also going to have current going through here. So there is another loop, okay, where R equals 0, just here on the right, not on the left, but it doesn't matter. It's still in the circuit. So again, current equals infinity. So that's another short circuit. All right. It's just important to identify short circuits. We'll practice with it more and more, but understanding what circuits will work and what circuits won't work. All of these circuits, when the switch is closed and current starts flowing through it, none of these circuits will work. Okay? There has to be some form of resistance in every loop. So what you're going to upload for your Google form today is you're going to follow the directions here. You're going to draw some circuit diagrams, not just pictures, but follow the circuit diagrams with the proper symbols. A series circuit and a parallel circuit. Make sure each has one battery, one resistor, and one light bulb. In your parallel circuit, make sure the resistor and the light bulb are in separate paths. Make sure there are no short circuits in anything you draw. All right, have a good one, guys.